Hi guys and girls, going over the solutions to some of the exam questions on angles today. So let's jump straight in. So we have PQ is a straight line, and we are told, well, we are asked to work out the size of the angle marked X. So if this is a straight line, then 126 and X must equal 180. So 180 minus 126 is going to be whatever angle X is. So that's going to give me 54 degrees. So work out the angle marked Y. Well, if this is an isosceles triangle indicated by these two lines, then this one here is also 54. And we can then use the angles inside a triangle, must add up to 180. So 54 and 54. I should be writing this down because I'm supposed to be doing it like an exam paper. It's 108. And then 180 minus 108 is 72. And so Y is 72 degrees. Give a reason for your answer. It doesn't have a letter, does it? So the triangle is isosceles. So angle Q equals 54 degrees, and angles in a triangle add to 180. There we go. Question 2. The triangle ABC is isosceles. Yeah, we know that because we've got this symbol here. With AC equal to BC. Angle ACD is 62. Yep. And BCD is a straight line. Work out the angle X. Well, if ABC is equilateral, this is also going to be the same as X. And this is going to be whatever needs to be added to 62 to make 180. So we should do 180 minus 62. So 118. So this angle here is 118. 118. Actually, there's an easier way to do it, isn't it? You can do it this way. This is the long way round. 118 angles inside a triangle have to add to 180. So 180 minus 118 is 62. And half it is 31. So 62 divided by 2 is 31. You could have actually done that straight away if you know that fact. If you're ever met with knowing the external angle of a triangle and you need to know its internals, the two that are left over are going to be the same as the external angle. Right, next one. What have we got here? A regular octagon. Work out the size of angle X. If it's regular, then all of them are the same size. And we need to know what they should add up to. So you can either memorize it or you can work it out. If you work it out, it's 180 times the number of sides minus 2. So that in this case would be 180 times octagon is 8 sides, so this would be times 6. This could come up in non-calculator, so hopefully you can do that. It's 1080. You've got to divide that 1080 into your 8 separate angles that would be inside your octagon. So we would get, oh, that's 20, so 3 would make 24, so I'm not going to have space. So 4 and then 5. So the answer is 135. Question 3. The size of the exterior angle of a polygon, regular pentagon. So pentagon, 5 sides, so it would be 180 times 5 minus 2, which is 180 times 3, which is 540. So the internal angles add up to 540. 540 shared out amongst the 5 interior angles is 108, meaning that this here is 108. And the exterior angle is 180 minus 108 because it's a straight line, and that's 72. Number 4, we know it's a quadrilateral, so therefore we know it's going to add up to 360. So I know 100 plus 47 plus 2x plus x has to add to 360. Simplifying, I get 147 plus 3x is 360. So 3x is, that's going to make that 113, sorry. Oh, what am I about? Sorry, 213, there we go. So x is going to be that divided by 3, which is 71. So work out the size of the largest angle. So 71 is not my answer. This one's going to be 71, but the angle at D is going to be double that, so it's 142. So your actual answer is 142. Number 5. A regular hexagon, same idea as it has been for the other regular shapes. So 6 minus 2 is 4. So 180 times 4 is 720. Share that 720 out amongst the 6 angles inside your shape, which is 120. Number 6. Work out angle Y. We know that the DE and FG line are parallel. So I have kind of Z shape there. So it's an alternate angle. This angle and this angle are the same. So my answer is 64 degrees. Easy peasy. Number 7 looks a bit more complicated. What do we know? We know that ABC is parallel to DEF. Yeah, that's all marked up, and we know that these two are straight lines. Write down the angle marked X. So I've got a Z shape here. Again, 48 and my X angle are the same, so it's 48. Give a reason. They're just looking for the word alternate. Or phrase alternate angles. Don't really need to go into a lot of detail. And then write down the size of the angle marked Y. So this one you've kind of got a backwards F shape. So you've got this angle and this angle are the same, which means Y is 30, and those ones are called corresponding angles. Right, number 8. So the diagram shows the position of 3 buildings in a town. Bearings. Bearings are always measured from north and should go clockwise, never anti-clockwise. So the bearing of the hospital from the art gallery, 72, that's that one there. The cinema is due east, which means that's 90, yeah, that's on there. The distance from the hospital to the art gallery is equal to the distance, okay, so it's isosceles, that's all marked up as well. Work out the bearing of the cinema from the art gallery. So you are at the art gallery and you need to get to the cinema. So you start at north and you go clockwise till you get to the cinema line, because this would be the line that you would walk along to get from the art gallery to the cinema. So you know it's going to be bigger than 72. It's just a question of how much bigger. What do we know? We know that that bit's 72. This is isosceles, and I've not drawn that very well at all. That's 90 degrees. Right. The key to this one is actually spotting that these two north lines are parallel. And then you can say that, well, this one and the 72 should add up to 180 because they are interior angles. So that's going to make that 108. You know, that bit there is 90, and it's got to go to 360 to be all the way around. So I've got 198. So that's going to give me 162. And it's isosceles, so this angle and this angle have to be equal. So 162 off of 180 is 18. So each one has to be 9 degrees. So the bearing from the art gallery is the whole distance. So you've got to go the 72 and then the extra 9. And 72 plus 9 is 81. So my final answer is 081. Bearing should always be done in triple digits, so hundreds, tens and thousands, so you should have that 0 in there. Last question. So it's another bearing. So let's put my north lines on the ones that aren't already on. Work out the bearing of B from P. So for that one you've got to start on this north line here and then go all the way around. Because from P means you're at P and you want to get to B. Right, so we need to know this angle here really. Well, it's around a point, so I've got 138 and 63 already. So that is 201 degrees. So to make it up to a full 360, I'm going to need 159 degrees. So x is 159. Is that what we're about? There we go. So the full bearing is 159 plus 63. So 222. And then of P from A, let me grab a different colour. Oops, there we go. That should be a 2 there. P from A, so you're at A and you want to get to P. So you've got to go all the way around there. Okay, well we can tell this angle here because 63 and that angle there have to add up to 180 because they're interior. So 180 minus 63. Yes, you should be writing all these out. Now I've lost my train of thought. What was I doing? Subtracting. 117. So this angle here is 117. So the bearing of A must be 360 minus 117. 5. I think I'm having a go slow day on my brain. There we go, 243 degrees. See you later.